Good evening, everyone. I think the waiting room is now empty, in which case we will make a start. Welcome to the fourth event in the series Towards Another Architecture, which has been organised by the Farrell Centre, which is a new public centre for architecture and cities here in Newcastle in the United Kingdom, in collaboration with the School of Architecture, Planning and Landscape at Newcastle University. Now, this is the fourth event in the series. So I've done this preamble a few times, but for those of you for whom this is the first event you've attended, I thought it'd be useful just to set up the framing, which is to a large degree the brief that we've given our speakers. So the starting point is the realization, I suppose, that it's now 100 years since the first essays that would form Le Corbusier's Vers une Architecture were published in L'Esprit Nouveau. Modern life demands and is waiting for a new kind of plan, both for the house and the city, Le Corbusier declared. And today we live at another pivotal moment, it's fair to say, for architecture and for the wider world. And this series emerges from the contention that what we need to make sense of this moment is not a new architecture, as Le Corbusier was popularly mistranslated as advocating, but another one, an architecture that is not bound to a single vision or future, but is diverse, pluralist, and sustains multiple conversations about the active role that architects might play in the world. So the series invites a number of practitioners and thinkers and researchers working in a range of fields and geographies to reflect on this pivotal moment and articulate their vision for another architecture. The format is a 30-minute or so presentation, followed by 30 minutes Q&A. So please have your questions ready. Last week, we heard from the curator Gonzalo Herrera de Lizardo, who explored the architectural implications of the metaverse. This evening, I'm delighted to introduce Professor Ruth Morrow, who will be familiar to many of you, not least because she is Professor of Biological Architecture in the School of Architecture, Planning and Landscape here at Newcastle. She also acts as co-head of School X, a new interdisciplinary school being established at Newcastle University. Prior to joining us, Ruth was Professor of Architecture at Queen's University Belfast, and before that, she was at Ulster University, also in Belfast. I won't talk about Ruth's research because I know she's going to talk about that herself, but it is extensive, as you can probably imagine, and she's also a noted teacher who's recognized for innovation in pedagogy. So Ruth, welcome, and over to you.
Okay, moment. So let's see if I can do this. So can you see my presentation?
We can.
Yeah, so full screen. Okay, so Owen, thanks so much for inviting me to contribute to the series of lectures on Towards Another Architecture. Since sending in my lecture title, and I think that was before last week's lecture, I've added a subtitle, which is maybe going to come up here. Creative material collaborations at other scales. It's somewhat in response to Gonzalo's lecture from last week. For those of you who weren't able to make it, his work sits chiefly within the digital realm, or at least he has a very strong interrelationship with it. To be honest, I couldn't always get my head around the thread of his argument last week. I think that's more about me being at a certain end of the age spectrum than him. But I did definitely recognize that steady, almost kind of dual drumbeat of enthusiasm and doggedness evidenced by the very impressive range of his output. And his work has stayed in my head throughout this week. So I could definitely see in him an architect that was working with the latest technologies, trying to make sense of them and thereby enhance the experience of space for others, whether that be virtual space or otherwise, and trying to find a place where his architectural skills and his values could be most effective. And that's exactly what I and those that I work with and have worked with over numerous years do as well. We're also trying in a way to bring our architectural savviness into scales of operation and to places where architects have not yet tread. But let me also be clear here, there are very many places currently, even within normative or normal patterns of construction of the built environment, where architects have very little influence. So this idea of another architecture that we're talking about this evening and as part of the series is not just about the future development of the profession, it's also needed with immediate effect. If we were in some way, I think, to quantify where architects are in society in comparison to where they could be, for me, there's a jaw-dropping, mouth-wide-open hole. For me, I think the most obvious and pertinent gap in our scale of engagement is the development of new inclusive technologies and materials, and that's what forms the context of the talk this evening. But I was also struck by some of Gonzalo's closing remarks, and you can see some of the quotes here, and really asking and talking about collaboration in his terms with coders, who he saw as the new building workers, but also with other engineers. And in this, I also strongly empathize with him. In the increasingly complex world that we face, it's a very trite phrase, but it's very much the case. Any contribution we make can only be through collaboration. So in this talk, I'm going to quickly pass through 4 highly collaborative projects that I've been involved in, none of them at the scale of the building. They're all complex, unique projects in their own right, and for each I could probably deliver 3 to 4 lectures. So it's been quite a task to ram them into 30 minutes. But I'll focus instead really on what I call the unpredicted or the unforeseen collaborations and insights that have emerged through that collaborative process. I'm hoping that at the end of this lecture that I will have convinced you to dispense in a way with trying to define architecture or indeed another architecture, and simply to focus on the practice of the architect in collaboration. And whilst the argument that the architect can operate at scales beyond the building is, I think, well rehearsed, at least I, and in fact quite a few in the audience, have been parading that idea for quite some time now. The point I'm making here is that as we move beyond the building scale, very different and revelationary forms of collaboration emerge. So this is the first project. It became known as Tactility Factory. It started off as girly concrete, and gradually we had to mature and grow up and all of those things. So it became Tactility Factory. It was driven by myself and Trish Belford. Trish is a textile designer of some note, who had many years experience in industry. She had her own factory indeed. And we came together with a very singular shared desire to make hard things soft. And that eventually morphed into bringing together the technologies of concrete and textiles to make unique outcomes. There were a number of stages in this 10 years plus material development project, which included conceptual design, technical innovation, theoretical grounding, which was important for me, and commercialization. The project was driven, like Gonzalo's work, by dogged persistence, like in fact the work of most creative practitioners, upheld, I suppose, by strong, confident articulation of what both of us understood as the act of making mad ideas sane. So this is a phrase that really resonated and worked with us all the way through. So although it began with the 2 of us, we very quickly required technical and creative input from a range of experts across textile technologies, glue specialists, and concrete researchers and precasters who understood manufacturing processes and mold and all of those things. As the project was scaled up and commercialized, we all also ended up collaborating with another layer of expertise, and that was investors, marketing experts, agents, and patent attorneys Indeed, the patent attorney very much helped us to bring focus to and articulate the technology, and indeed own the technology. And I don't just mean that in the legal sense, but also emotionally. An odd thing to say, isn't it? But this is particularly challenging, I think, since neither Trish nor I come from cultures that necessarily understand intellectual property, or IP, as people call it, let alone its role in the commercial world. And indeed, as a textile designer, Trish had never thought of her processes of manufacturing and transforming textiles as technological. Indeed, she would never use the word technology, despite the fact that she used fairly, what I would call hardcore combinations of chemical and mechanical processes. The term technology is, of course, historically gendered and rarely assigned to the societal processes that women are traditionally involved in. So odd as it might seem, that collaboration with a rather kind and extremely patient patent attorney became a very significant turning point for this work. But perhaps the most interesting collaboration in this project was really between the concrete and the textiles. Alone, we used fairly ordinary, familiar technologies. So individually, the concrete, for example, both in terms of mix and the molds that we used, is fairly recognizable to anyone within that, with that background. And indeed, any textile designer would fully recognize and understand the textile technologies that we were using as well. I mean, with little tweaks here and there, I suppose. But those worlds rarely come together. No one really saw the potential of this marriage other than us. I suppose we had a certain belief that if we just kept going, we could make this work. And I can tell you those 10 years were definitely needed. The early samples and early work that we did were lumpen and leaden, and I mean, I could show you them, but not tonight. But one of the patents, or one of the 3 patents that we hold in this work, that is the most evocative, really, it's the one in the center of this image that you see. So there's a beaded crystal, which is the same technology you would use if you were doing haute couture evening dress, and the velvet on the far side. And in the middle is linen. This is probably for us the most extraordinary material collaboration. Linen, as some of you will know, is a cellulosic fiber. It's wonderfully resistant to the alkaline environment of concrete, and its relationship to water also means that as the concrete and the textiles cure in place, the linen then shrinks. I don't know if people know how receptive linen is to shrinkage, but it is. Most of the linen we buy is being pre-shrunk. But it pulls back into the surface and reveals, because of the way we've designed the textile, reveals a highly articulated surface. And that by any other means would be extraordinarily costly in order to replicate by any other means. So any post-production processes or complex mold making would cost a lot. In this instance, the linen does the work for us. So we came to call this linen and concrete our vinegar and chips, because as anyone who loves vinegar and chips will know, that those are 2 substances, rather odd, that somehow come together in a very natural and easy collaboration. The second project I'll go through is an Ireland US funded project that I became involved in very early, well, right from the outset, which looked at the problem of waste wind blades from the wind industry. This sounds like a very niche problem, a very technical one at that, not so exciting. However, the wind industry is rapidly expanding across the Northern Europe and on all coastal regions of the continents. The problem of what to do with waste wind blades is large on every scale. So wind blades are decommissioned after 20 to 25 years of usage. A typical 2 megawatt General Electric turbine has 3 blades on it, typically between 57 and 62 meters long, depending on the model, of course. And that is approximately 20 tons of waste at the end of its life. The turbine itself, in comparison, can be recycled numerous times, and has eventually got scrap value. Of course, what we don't talk about is the massive concrete foundation at the base of these wind turbines. But the blades themselves have to be removed and disposed of, because if they fail, it's catastrophic. And I don't know if anybody, you can just look on YouTube, wind blade failure, that will put the fear of God in you. So it's a particularly tricky type of waste, because for the most part, these blades are made of what's known as a thermoset matrix. And that is just impossible to take apart, really. And it's predicted that we're going to have 39.8 million tonnes of waste by 2050. One of our students did an amazing calculation and understood Northern Ireland as a 2.8 deep swimming pool, and reckoned that by 2050 it would be full of wind blades. So quite an amazing way to think about it. And these images that are on the screen, in the past, before I got involved in this area, I definitely understood all of the positives of the wind industry, all of the things that it can do for us. And often I would look at these in quite a poetic manner and think on those amazing structures in the landscape. But actually, having gone through this process, I now see them as industrial litter. And it's something we do need to think about. So let's see if I'm moving on a bit. So the current means of disposal are not ideal. So we landfill them. Often they're dropped into the sea. Most of the companies that own them are also still trying to decommission their coal-fired power stations, and so they'll also incinerate them. So there is no decent way to get rid of this massive amount of waste, which is exactly where our project sat, was trying to come up with ideas around this. So of course the team involved was both international, because this is a global problem, but it was also multidisciplinary. It was made up of engineers, material scientists, social scientists, we had LCA experts, we had business modelers, and we had wind energy experts who understand just the makeup and how the industry functions. And we also had two architects, myself and a colleague from Georgia Tech, and we had our architecture students, which were a brilliant bonus. So the one group on this list that I had no experience of working with were the GIS experts, the Geographic Information Science experts, the team from Queen's. It's quite a small team that was on this project. But as we unpicked the issues, and these are some of the diagrams that some of the master's students created in readiness for what we thought would be a design brief, but turned out to be something entirely different. We realized that only through GIS could we really begin to understand the scale and order of the problem. So we attempted to plot the wind farms and the individual wind turbines. And this information is not easy to source. There is no one place to go to. You have to first of all ask for the data banks of the companies, and of course they will give you that, but in a very limited way, and they're usually not updated. We often had to manually log. We had to go to planning applications that were for single wind blades or smaller groups, maybe not owned by a large company. And we also then had to double check through satellite imagery. But the GIS team who did all of that, so the architects are not involved in that, really mapped that problem, and they did it visually, which of course is the most easy way to communicate. And through working with them, the wider team and our design students were able to road test some potential solutions. So I'm not going to go into too much depth about this. I'd love to, because it's absolutely fascinating, but just to give you some insight, we were trying as a group of researchers to work through whether the solution would be a science-led one. So that is, do we wait until science comes up with a clever way to get rid of the stuff that science came up with in the first instance? Or would the solution be a market-led one, where the demand, potentially in a remote but big market, would emerge, and then we'd ship all the waste off to the highest bidder? Or could we instead, as a research team, start to think environmentally, putting in place better policy, better governance, even at this late stage in the process of wind farming, and decide that we shouldn't ship this material any further, and indeed start to allow local communities to see it as their resource and deploy it as and when they need it. Of course, then the problem becomes one of where do you store such large scale waste? And indeed, in the recycling and upcycling industry, storage is a major component of how they handle and feed through into a supply chain, I suppose. So the students came up with a possible solution, which was Second World War airstrips. And the GIS team were then able to identify and plot the relationships between wind turbines and airstrips, and determine what we ended up calling kind of a center of gravity for the required storage. At the end, I think, of that project, we had a group of certainly architecture students and architects and staff who had insight gained very immediately through their collaboration with GIS team into how supply chains, logistics, and big data give form to physical outcomes. In a way, sustainable logistics is, for me, the new geology of what we do. So this next project is called Transplastics. I'll just take a sip. It also addresses the problem of plastic, of waste. In this instance, it's plastic waste. This was an EPSRC funded project, and I led on a work package. And our aim was to design and prototype a building block around circular principles. Essentially, what we wanted to do was to bring design thinking and user experience into very early stage development of materials through a process of critical feedback and evaluation. This was done in acknowledgement of the fact that the alignment of user values to technological advancement is critical in underwriting the adoption, the longevity of emerging technology. So that's a complex way of saying you need users to understand products in order that they keep them for longer. So we don't want to cycle things through. We want people to know value, how to use them, and they keep them for longer. So this example of early stage user experience and interaction in the process of material development is what's interesting in the context of this lecture. Although in the context of this project, it was an incomplete process because of COVID. The user interaction was critical for us for a number of reasons. So there are examples already out there of recycled plastic blocks that are used in buildings. They come from a very technical driven way of thinking. They are still quite niche. And they are very typically aimed at low-cost construction, also for what we term the underserved communities around the world. And as ever, it's the poor that carry the burden of the excesses of the wealthy, and it's the poor that we also experiment our emerging technologies on. Anyway, but these blocks in the end tend to get covered up with render and other materials, and they're fixed in place by other materials again, and they don't actually fulfill a circular brief. And that's also because they kind of have no material experience. They're only doing a technical role. At the other end of the scale, and you can see this work by Shara Mendelsohn, who's an artist based in New York, and she goes out of her studio in the morning and collects the plastic bottles and recycles and shapes them into these extraordinary sculptures. They really have an aged, ancient feel to them. And of course, she's also influenced by early glass work. But we also know from the literature on upcycling, which again is a good body of literature to refer to because it's a value-led process, that a product that's imbued with values associated with reusing waste material that even holds echoes and traces of its former life has a very strong ethical environmental appeal. So we didn't just want to design and prototype a building block. What we wanted to do was design and prototype a beautiful building block that held an echo of its former life. So the team was made up of, we had some students involved in this, we had polymer production researchers. In particular, we worked with rotational mold experts because that's a very cheap, generic and ubiquitous form of manufacturing plastic or forming plastic. We also worked with a real life practicing architect. So having somebody like me or some of the researchers I work with on board for me wasn't enough. We definitely needed a practicing architect who brought amazing skills to the project. we had a psychologist, we had a polymer scientist, material scientist, and we also had a bank of what we called critical users. It was intended that they would be quite a wide range of people from different backgrounds and different perspectives in society. But in the end, because of COVID, the only group that we got to before COVID stopped this process was a group that we met through Guide Dogs for the Blind, so they had visual impairments. So it wasn't ideal. And I suppose these are some of the images which I could talk about, but not now. But so alongside working in parallel with the designers and the production experts in order to understand the form of the block and how the means of manufacturing would impact on the nature of the block, as I've already said, we had a polymer material scientist who focused on establishing the mechanical properties of the recycled plastics that we were intending to use and their capability to be molded into the blocks. But she was actually a trained architect who had gone back to retrain in chemistry and ended up doing a PhD in polymer science. And she was very interested in the blending of polymers with other waste streams such as hemp fibers and sugarcane, red mud, also recycled crushed concrete. You'll get a glimpse of that later on. And also you can see the two discs in the middle. These are what's known as jazz PET, which is a kind of familiar waste plastic. But what was fantastic is that it melts at a different temperature than the kind of substantial plastic that surrounds it. So it kind of has a different appearance. From the outset, we planned to bring early material samples and scale models into a workshop with people, as I've already explained. And in this instance, it was only with the people with visual impairment. But even despite that, those limited conversations that we had provided really useful perspectives that impacted on the evolution of the polymer mixes. The user groups had very positive reactions to the most textured plastic samples. You can probably see a little bit of that in this slide. But on closer inspection, I think the surface of the plastics, although they appeared to be visually smooth, had micro undulations on the surface. They were only picked up by the people we spoke to being able to touch in really sensitive fingers, obviously, and they were going, oh, that's really interesting surface. And of course, we had been spending our time looking at them visually, going, oh, I like that color and whatever. But that undulation was really important to them. And of course, normally within polymer manufacturing, that kind of those slight undulations or differences on the surface would be seen as a flaw. And that would just be abandoned. So a technologist involved in this would just go, no, that's not going to give us the technical performance that we require. The term claustrophobic, in fact, was used by one of the visually impaired participants, describing the surface of the samples as being so smooth that they offered little to no sensory response. And they talked a great deal about the lack of sensory stimulation in the built environment in general. And we really heard that. Without that interaction between people and with visual impairment and the project outcome, let me just set that going. I think the project outcome would have not been as successful as it was. I mean, this project is still raw and first steps and has far to go. But I think the outcomes are interesting. The collaboration meant that the project stepped beyond simply responding to the demands of manufacturing processes and the technical performance of materials to respond to criteria of human or humane performance. So moving from the technical performance data that we're obsessed with in the world of materials to kind of understanding a level of humane performance. Only by bringing design thinking, designers and their sense of others, of working for other people, for society in general, I think into the early stages of material development can this happen. Okay, so the next project, let's see if I can stop that. Yeah. Finally, this is the last one I'm going to talk about. We're currently working on a number of living prototypes in HBBE. I'm just going to talk about one of them. This is a bacterial cellulose facade prototype. It's probably, I mean, I often think of it as being probably the most speculative and risky of the prototypes, but to be fair, I think all of our prototypes are highly risky in the Hub for Biotechnology. We are aiming to use bacterial cellulose as a facade material. And you can see here the bacterial cellulose or microbial cellulose. So cellulose is the thing that is secreted during the lifespan of certain types of bacteria. Is their waste. I quite like that idea that we're harvesting the waste of microorganisms in order to do this, particularly in the context of windblade waste. So we would typically understand this from kombucha, where when you drink your glass of kombucha, it has that nice vinegary, tangy taste. To create kombucha, we've got this kind of a kombucha mother that goes into it, and then this kind of pellicle forms in the upper surface between the air and the liquid. And it's that we're harvesting in this instance. There are other ways to make microbial cellulose or bacterial cellulose, but here, this is how we're doing it. But it's a great material. So whilst it's a waste material in some ways, it's a great material. It's relatively robust, it's biocompatible, and inevitably biodegradable. And as a resource material, it can grow anywhere under relatively easy to achieve conditions. And unlike many other living or growing materials that we're starting to turn to again, it doesn't rely on land that would otherwise be used for food. But we are at the very, very early stages of understanding it and its potentials and its challenges outside of the lab. So a lot of the knowledge is understood. A lot of the knowledge of this material is within the lab. We're bringing this outside the lab. Other people have done this, but maybe not. Well, in fact, absolutely not for the built environment. And like most living things that we've just met, we're working hard to build a relationship, a collaboration with it. We want to know what's going to make it happy, productive, and what's going to expand its lifespan. We're trying hard not to assume or imprint previous material relationships and collaborations onto it. So instead, we want to work with it or with them rather than make them be what they're not. We want them. We want to better understand them in order to help them be what they can be. So it's a very different relationship to normative or traditional building materials. This collaborative relationship with living materials is something that many of the researchers in HBBE are facing. And this is the amazing work of Dylan Ozkan, who is working with fungi and biodigital fabrication. She's closely observing the growth patterns of fungal growth in order in controlled and indeed controlling conditions. So she can tweak the conditions to see how the fungi grow. This has allowed her over time to predict how the fungi will respond. This lower drawing shows possible ways in which the fungi might be. And I've heard Martin Dade Robinson, who's our lead supervisor in this, and Dylan refer to this as being the space of probability. It's a brilliant term, brilliant phrase. And to some extent, it also echoes the term that engineers and architects use with standard everyday materials, where we talk about tolerance, we talk about building in tolerance into our designs, where we allow for certain or different materials, different behaviors to occur in different contexts. So for example, an easy one to think about is sometimes if you walk along a concrete path, you'll see that every so often there's kind of a break line that might be infilled and just gives it a bit, they're poured in certain sections. And that's because it just gives it a kind of a tolerance, a space to expand if need be. And it's usually to do with environmental conditions. But this language of tolerance and building in tolerance and allowing for material behaviors is, to me, somewhat slightly passive-aggressive way to collaborate with the material. So they can do stuff, but only within a certain tolerance. In HBBE, we recognise how little we understand of the potential of these materials. We're intent in collaborating and learning from them. And of course, we also fall into traps. Hands Up Ruth did this one, of trying to conceive of their application in similar ways as normative materials. So in this instance, you can see this is bacterial cellulose. that's hung outside. You can see it if you go to the outside of the Ohm. And this is in some way making reference to wooden shingles that are on the side of a Swiss chalet. And this may or may not be the way that bacterial cellulose wants to be used, but this is where our starting point for the moment. But we also shouldn't forget that the collaboration or relationship that humans have had with, for example, wood has been ongoing for 10,000 years. So here, for example, is a wooden lined well that was found in Central Europe and that's been dated as the world's oldest wood architecture. It's between 5099 BC and 5206 BC. But they also, there's kind of a little footnote in this paper, which I find quite extraordinary, which says that they found reused timbers, which were excavated from our surrounding pit, which were more than 100 years older than the wall lining itself. So clearly these guys have been building these wells for generations. The construction may look crude. I suppose that's the first reaction to it, but the 3D scans allow us to see that only with the tools that they were using at the time, they only had stone or bone, so there was no metal in this period of our history. They were still able to achieve very highly crafted elements that slot very, very well together. Indeed, the individual pieces are almost a piece of art in their own. And the timbers themselves were taken from very large 300-year-old trees, and they were cut to length using fire. This is highly skilled work using the technologies of the day. And so we should use the technologies of the day too. So how do we hope to build the equivalent of 10,000 years of collaboration with these new materials without working for 10,000 years? I think the biodesign community already has a march in this problem. It's a young community, and as I say, it uses the tools of the day, the tools to hand. So not just the lab, not just the kitchens they work in or the workshops, but also online fora and social media that connect these communities. So this one is a Fab Forum. It's generated in collaboration between Elise Elsacker, who's one of our postdoc researchers in HBBE, who is also an architect by background. I should also say Dylan is an architect by background. And Elise put this together with her fellow founders. It's a DIY community that's engaged in experimentation. They have feedback loops, knowledge exchange around the manufacturing of a range of biological materials. They exist in the digital and they come together in the real world, the material world, to work and experiment with these living materials. So it's not only a demonstration of hive mind, but to some extent it's hive hand. It's potentially a kind of crowdsourcing of crafting expertise. This is something we're particularly interested in HBBE. Kaj and I are kind of working up some ideas around this, which we think is the next intelligent move that we can do, particularly around bacterial cellulose, where we ask the real and the digital realms to collaborate, bringing together citizen scientists and DIYers and crafters to interact with these new living materials, condensing in a way through mass collaboration 10,000 years of material experience. So I think I'm nearly done. In summary, so I've covered lots of different types of collaboration, but there's one overriding characteristic for me, which is collaboration, when it's most successful, takes you to places you cannot foresee, where other forms of collaboration emerge. So it isn't just between people, it's between materials, it's between us and non-humans. But what does that mean for the architect? So over the last few years, I've been really trying to understand this notion of how do we genuinely co-create with others. And I've turned to improvisational theory as a way to understand that. It's a very rich body of theory that helps, because improvisation, if we think about it, is always in collaboration. I mean, one can improvise within, I mean, it's usually within, you know, we associate improvisation with music. So we can improvise within a given text, within a given piece of music. We can also improvise with space. I've also seen musicians who improvise in collaboration with their heartbeat. They wire themselves up and they make music that responds to their body. And of course, the most obvious is that we see people improvising music together. So it's really fascinating. There's lots of theory around how this happens. That body of theory uses the term adaptive expertise, which refers to knowledge and skills that are circumstantial and contextualized within the improvised event. Adaptive, like normative expertise, is gained through practice and experience. And this is the crucial bit, but rather than being asserted in the improvisation, it's attested to in the practice before the improvisation. So what that means is that in the preparation that allows the actor, the improviser, the collaborator to be responsive to the context, and ultimately adaptively expert with others. So to be in collaboration, I think we have to be good, ethical, skilled architects, assured of our expertise, but we also have to set our expertise to one side and not assert it when we come into collaboration with others, whether that be in the online or face-to-face world, whether that be with other disciplines, people, materials, non-humans, and whether that be at whatever scale it takes us to. In other words, we have to be able to give ourselves over to collaboration. And that's my final sentence. So thanks so much. I will stop sharing if that's okay. I can't hear anything.
Thank you so much, Ruth. That was absolutely fascinating and amazing to condense so much into a comparatively short talk. So thank you. So this is the opportunity for questions from the audience. There's already been one posted in the chat, which we can come to very shortly. So if you have a question, please post it in the chat, and then what we will do is we will come to you, and Mike will unmute you, and you'll be able to ask your question directly to Ruth. As there is one already in the chat, I think let's go straight to that. So Katie, if you were there.
Hi, yeah, I just had a quick question. When you were talking about biocompatibility, I was wondering, do you mean with other building materials? And also, how can biocellulose be integrated possibly with existing structures to expand or adaptively reuse, what's already in our built environment?
Yeah, so it's a really great question, Katie, for lots of reasons. So the first bit, the biocompatibility, is to do with the fact that bacterial cellulose is mostly understood within the realms, in terms of research, within the realms of medical industry and food industry, because we ingest it when we drink bubble tea. And there is a Filipino dessert, which is natto de, my colleagues are going to laugh at me pronouncing this, but I think it's natto de coco, which is bacterial cellulose. Because it absorbs so much water, it also absorbs flavor. And so it's a traditional pudding. But in the medical world, it's used a lot for dressings, and they're thinking about, inserting it below the skin as well. So there's a lot of work on that area. That's what I mean by biocompatible. But the idea of using it with existing materials, so the one thing, I'm part of a research theme within HBB, which is called responsible interaction. And I suppose the title of it kind of gives you a clue as to where we think we're going, which is, it's all about interaction, it's all about collaboration, but it's equally about working with existing materials and some of these new materials. Now, we haven't got that far, Katie, on that journey, but the hope would be that we could use these materials together with existing technologies. We do have one, I work with some students as well, and I've been working with one student who's been thinking of using bacterial cellulose as a kind of fabric formwork with mud construction. So we're definitely thinking how we can bring these things together. I also have another student who is working on ideas of how can we make bacterial cellulose more like concrete, and how can we make concrete more like bacterial cellulose? And that's kind of blending those technologies. So there's definitely ideas about putting bacterial cellulose within construction. And indeed, we're going to try a little bit in the future because it's so wonderfully absorbent of water. We might be able to use it in, I have another project around bioreceptive concrete, that we might be able to use it as a kind of water holder in a way. So yeah, that's where we're heading. If you've got any ideas on that, Katie, just let me know.
Thank you so much.
There is another question that's just appeared.
Yeah.
From Delena.
Yeah.
So wherever you are you here? I hope so.
Yes, you can hear me?
Hello.
Yep.
Yes.
Wonderful. But I was just asking, do you think like increased opportunity for interdisciplinary education, like schools communicating and offering more availability for classes, would help like increase the like consideration and like cross-cultural solutions to like certain problems and issues?
Yeah, I mean, Dylan, you're definitely reading my mind. So this, I think at the outset, Owen made reference to the fact that I've become a co-head for SchoolX, which is in Newcastle University. So I don't know if you're part of Newcastle University, but this university's been thinking for a while about how do we get more cross-disciplinary, interdisciplinary work going on, both in learning and also research. And one of their solutions, because it's not the only solution, there is never one solution, was to form SchoolX, which is what we're in the process of doing. And that is very much about making those connections across disciplines. And I mean, the answer is yes, and this is the direction of our travel. I'm still very respectful, as you can hear in that kind of final statement, of people being expert in their own area. You know, I don't want to change that. I still want people to be in that, because I think that bringing that expertise into these kind of open collaborations is an amazing thing to do. But there is also a need for people who can translate between the different disciplines and who can manage that process. I think to some extent I'd argue that architects are brilliantly good at doing that, because even if you think about how we go onto the building site or how we make buildings happen, we are quite good at managing across different cultures. You know, so we might be working with a brickie, but we might be speaking to a planning consultant and working with a client. So we do, at least we do have an ability to be able to speak across different languages. And we do that because we're also using what those GIS guys use, which is the visual, to do that. So I'm really in this zone. I think it's really important for us to explore it in universities, because of course, you know, universities are the way they are. They've kind of congealed around a certain format, but that doesn't have to say that's how we go forward. But yeah, I don't know if that answers your question, but I think my answer is yes.
That does. Thank you very much.
Yeah.
I will ask a question as we the chat has gone quiet, but so if you do have something you'd like to ask, please do put it in the chat. But in the meantime, I guess kind of picking up on a point you just made about that, the architects taking that role of translators, and I was wondering about the role of language in this, and it may be a question that you're asked a lot, but collaboration depends on a kind of a common language, or at least a kind of common vocabulary. And I was wondering if you could perhaps talk about how if indeed that is the case, how that develops and what kind of approaches can be taken to kind of accelerate that process.
Yeah. So again, both really good questions. So language is really central in collaboration, and it is, you know, entering a collaborative project is like going to a foreign country. I mean, it really, I mean, I've had that experience. I, as a young woman, I went off to live in Germany and I had no German, right? And so I had to gradually learn the language of the country. And so the first part of collaboration is always euphoric and, oh, how exciting this is. And, you know, it's a real honeymoon period of just loving being in another culture. And then there's a bit where you start to lose your confidence in yourself and your own ability to communicate. And there's definitely a bit where you go, these people know so much and I know not, you know, nothing. And there is this bit where you kind of lose and you want to go home. You just want to go home. But if you stick at it, you then find that you can understand them and they can start to understand you. And then what happens is you do create a third language, a kind of interstitial language that occurs. And it was my experience, particularly within Tactility Factory, that, and it was a lot to do that we're also quite playful and we allowed it to happen and encouraged it to happen and came up with different, you know, phrases. Language was so central to it. And by the end of it, we had people using the language that we were, you know, we'd have different names for different things. And we had people using that language, stringing it in a sentence that had never been said before in the history of humanity. And I think those are indications when collaboration is at its richest, that all parties have begun to buy into this new way of acting and thinking. How you speed it up, how do you get people to that part? That's definitely something I think we need to do an awful lot more thinking around. And certainly School X, I believe, has got to do a serious piece of research in this, because we can't, it's a bit like the wait for 10,000 years to understand wood. You know, we can't just wait until collaborations naturally occur. And in part, I would say most of the collaborations occur because people like the smell of one another. You know, they kind of get one another in part, or there's something else. Maybe they have you know, they go to the pub, you know, they have some sort of social interaction that binds them at a different level. But we also want people to come together who've never collaborated before and culturally don't even fit together. You know, that's really where diversity starts to reap benefits. But that's about managing it. It's about understanding exactly what's happening here in this relationship. What are the phases of that relationship development? And can we do something to support that? I don't expect every researcher to understand the psychology of collaboration, but I'd like to see them being supported through that process. I think that's pretty critical. And more than anything, we need to understand it better. And I think we're being amateur in our views towards collaboration at the moment.
Yeah. Another question in the chat. Ruth, do you want to answer it directly from the...
Yeah, with cross-cultural linguistic communication, do you think large-scale comparisons of countries influence building materials and methods? I don't quite understand that question.
Sorry, it's me again.
Yeah, you'll jump in and
I was just asking, because earlier you mentioned how when you were looking at the plastic building blocks that were solely for like material usage, not like any aesthetic things or interactions with sensory input, but you mentioned how we were always sending them to what the UK would deem like an underprivileged country, or like one of those areas, instead of trying to integrate any of that technology and recycling plastics into like our infrastructure. Mm-hmm. So like, do you think global interpretation and like impression of countries influences like how we're treating building aid in areas or like developing in our cities?
I don't know. I still don't quite understand the question. I mean, I'm not. So the building industry is global. You know, if you just, I think there was a paper I read maybe about 2-3 years ago, which I don't remember all the stats on it, but it described the shipping industry that supports the export and global transport of cement around the globe, and it is to do with this kind of one recipe, you know, that we've got it and we can export it around the globe, not recognizing that indeed there are multiple recipes for cement and concrete for that matter, and that they have existed for eons in different guises around the world. So I'm not into global industry. It's obviously unsustainable, and it's culturally void, and I worry about us exporting things. I think actually I was thinking about it this morning, about the kind of dark side of the living materials. I mean, I mentioned it that when I was talking about bacterial cellulose, that it can effectively grow anywhere. And that then, if we think about the diversity of building materials that surround us, and it goes to that idea also about stimulus, that we're surrounded by materials that we sense and we have a sensory response to, and there's a cultural response to those materials as well. I wonder where the cultural element will come with these new materials, because they're not linked to the geology of the region. So the bricks here are different from the bricks in Manchester and bricks in Belfast and whatever. So but bacterial cellulose is not necessarily going to be different here than it is in somewhere else. So I wonder about where the cultural reading of that material will occur. And it could end up being a relatively bland aesthetic that just, again, kind of becomes this kind of international aesthetic, and that horrifies me. And then I think that's the doomsday scenario, Ruth. So maybe it then goes back to what I was kind of hinting at, which is that we can build communities that understand this material, and maybe they bring their craft, and maybe we see things like decoration and pattern making and texture that become embedded culturally back into these, or not back, but into these materials. So I'm puzzling that through at the moment. I haven't come to any outcome, but it's something I think maybe some of my colleagues in HBBE can talk to me about as well, how they feel about that. What is the difference between bacterial cellulose in Belgium than it is in Belfast? Yeah. I don't know if that answers it. Does that make any sense? Yeah, that may. I mean, it's good to keep asking questions. That's I like that aspect of you, Dillian.
We have time for probably a couple more questions in the chat. I mean, I in my notes, you've kind of preempted one of my questions in a way, but I was quite interested in the role of aesthetics in all of this. So you showed those extraordinary vases made from, I guess, transformed plastic bottles, and they sort of, as you described, took on the quality of these very ancient objects. And I was kind of interested in the role of familiar aesthetics or aesthetics that are already kind of very culturally loaded, as almost a way, as a sort of, as a decoy in a sense to pushing forward materials that are seemingly very alien to what we think of as traditional building materials. And I was interested, I kind of, in my preamble, spoke about Le Corbusier and modernism as the kind of the starting point for that, and where there's obviously a very close relationship between a set of building technologies and an aesthetic that was developed to evoke the new, essentially. There's the appropriate aesthetic for concrete, for steel, for plate glass, for example. And I wonder how this then, what the aesthetic possibilities or aesthetic implications are for the materials that you are exploring. And when you mention, that sort of lack of geological specificity, which is really interesting, because of course that is all, you know, materials were used regionally essentially until the advent of modernism, and until until not, I guess, not just the new technologies, but the aesthetic that accompanied them. So lots of terrain, but where does aesthetics fit into this, I think, is what I'm trying to ask.
Everywhere. Aesthetics fits everywhere, and oddly within architecture we don't really talk about it, and of course when we do, we think of it as an elite thing, that it's just something that we as architects can talk about. But of course aesthetics is part of our value chain. It sits beside ethics and politics. It just so happens that it's a more implicit aspect of that value chain, and we don't, I mean, we would be a better society, we would be more aware of one another if we exposed our aesthetic choices and decisions, all the aesthetic nuances that lie behind our decision making, if we expose that to one another more clearly. So aesthetics is fundamental to everything that we do. It is an elite thing, and it's something we need to talk about an awful lot more if we want to look and have a fair or more open, transparent, and fairer society, I suppose. But when it comes to these materials, I think that is my thing. Who draws the aesthetic out from this? So it's not embedded in the nature of the material. It's not going to be or there's not going to be aesthetic divergence in the nature of the material. There could be, because of course we can go and engineer all of these things, and maybe that's where the aesthetic is. It's at the genetic crafting of these materials that it could emerge, and I'm sure I've got lots of colleagues in HPB who can talk about that, and that might be a recipe that's very unique to a region, because the IP sits within that region or sits within that manufacturer or whatever. Or it could be at the other end of the scale, which is where we start to think of social aesthetics, where we, as I say, co-produce them, where we understand those materials and together we make them. And I suppose my politics, my ethics, and to some extent my aesthetics draws me to that position. So I'm interested in co-producing. That's why I talk about collaboration tonight, not about me, So, and I'd like to think that those aesthetics are drawn out through a collaboration. But I don't have an answer that's neatly parceled to that one. I'm sure lots of people on here do, though.
Well, unless there is anything further forthcoming from the chat, I think we will draw things to a close. So, Ruth, thank you so much for that incredible talk and talking through some amazing work, and you mentioned this could form multiple lectures, and I hope that we get to hear some of them in the near future. The series picks up again next Thursday. We're at one event a week at the moment, and we will be joined by the Budapest-based design studio Paradigma Ariadne, which among many projects has recently curated the Hungarian Pavilion at last year's Venice Architecture Biennale on the theme of othernity. So please join us then, and for future talks in the series. But for now, Ruth, thank you ever so much.